Hey everyone, we're going to use angle bisectors of triangles, and this video is mainly informational with definitions and examples and theorems. So it's like an introduction. Okay, so the vocabulary you need to know for this video is incenter. And that's a point of concurrency of three angle bisectors of a triangle. So here is a theorem. The angle bisector theorem. If a point is on a bisector of an angle, then it is equidistant from the two sides of the angle. So if AD here bisects angle BAC, so this is your bisector and it's intersecting BAC, and DB is perpendicular to AB, and DC is perpendicular to AC, then DB equals AC. So these two equal. Should have made that bigger. And then the converse of the angle bisector theorem. If a point is on the interior of an angle and is equidistant from the sides of the angle. So do you see how these two are marked? Then it lies on the bisector of the angle. And so we have that. So it's just the converse of that, the if-then statement. This is if P, then Q, and this one's if Q, then P. So it works both ways. So let's find the measure of angle CBE. So we need to find this measure here. Now, because EC is perpendicular to BC and ED is perpendicular to BD, and these two are the same value, by the converse angle bisector theorem, these two angles are congruent. So that just means that angle DBE is also 31 degrees. So there's just a small example. And here's a real world example with the spider web. You can read that. So where's the spider? The spider is right here. Okay. And the congruent angles tell you that right here that the spider is on the bisector of L, F, and R. So L, F, and R. So this right here. And by the angle bisector theorem, the spider's equidistant from here. So the spider must move the same distance to reach each edge. So from here to here, or from here to here, and so forth. Okay, so let's look at some algebra. We need to know what makes P lie on the bisector of angle J. So, like that. So, that means these two sides have to be equal. So, set them equal to each other. We have 2x minus 5 equals x plus 1. Subtract the x from both sides and add the 5. And these two will cancel, so you get x equals 6. So when x is 6, P lies on the bisector of angle J. All right, and here's another theorem, concurrency of angle bisectors of a triangle. The angle bisectors of a triangle intersect at a point that is equidistant from the sides of a triangle. So if AP let's do this in yellow, AP and BP and CP are angle bisectors of the triangle, then these angles, these sides equal each other. All right, and so here's an example. Use the concurrency of angle bisectors. So let's see. We got to find LK. So we got to find this one right there. So we have this length is 15 and this length is 12, and this is a right angle because L, this is L, is on the point of the angle bisector. So, or L is the incenter. So here's our L. L is right here. Sorry about that. So it's equidistant from all sides of the triangle. So we're going to have to use the Pythagorean theorem to find this. So here's your L right there, and this is I. And then we know this is a right angle. So use the Pythagorean theorem here, and you get Li is 9. So if Li is 9, so that's 9. And then from what I drew here, these sides have to be congruent, so that this means all these sides are congruent. So this side is also 9, because these are your angle bisectors. All right, and then we have a little checkpoint. We got to solve for x here. So we're just setting these equal to each other. So we have 3x minus 5 equals 2x plus 5. So subtract 2x from both sides. Add 5 to both sides. And you get x equals 10. And we can do the same thing for this one right here. So we would say that, let's see, 8x equals 7x plus 3. Subtract 7x from both sides of the equation, and you get x equals 3. So that's all they did there. And then it says, do you have enough information to conclude that AC bisects angle DAB? So do we know from this that these bisected, so that these two angles will be congruent? And the answer is no, because these angles have to be perpendicular before you can conclude. These angles here are not perpendicular. They're just congruent. Now it says in example 4, we're not given HL or HI, but you're given that JL, so here's JL, is 25, and that JI is 20. Find LK. So we got to find this side. So we know that these parts right here are, these parts here are congruent. So let's just erase this. I should have made this bigger. So basically, let's just do the Pythagorean theorem first. So we have JL is 25. That's your that's your C is 25. And then we'll call JI is 20. So we have A squared plus 20 squared equals 25 squared. So that's going to be a squared equals 400, well, not equals, plus 400 equals 625. Subtract 400 from both sides, and you get 225. And you square root both sides, and we want to take the positive square root. So when you take the square root of both sides, you get a is 15. So in that case, our a is going to be Li. So we had this side. So Li is 15. And then we have, what are we trying to find here? Lk. So Lk is this one. And this one goes with this length. So these lengths here is going to be 15. So your answer is 15. All right. And that's it. Thank you. Have a nice day. Bye-bye.